Welcome to Engineering Influence, a podcast from the American Council of Engineering Companies. And today we're going to be looking at more of a technical issue related to engineering, especially those who are engineering industrial facilities and facilities that have a lot of particulate matter in the air through the work that is being done at the end project owner. And that's important considerations when you're looking at specifying an industrial dust collector. And to talk about this issue, I'm very pleased to be joined by an expert, and that is Randi Huckaby. She is has been with Camfil since 2014, and she's been serving in the field of manufacturing engineering for 14 years. And Randi holds a BS in mechanical engineering and an MBA from Arkansas State University, and she is the project manager for dry filtration air pollution control at Camfil. Randi, thank you for joining us.
Yeah, thank you for having me. I'm glad to be here today.
Well, to start off, let's give a little bit of a background on Camfil, the company that you're with. What do you do, and what kind of the products do you produce? Of course, air filtration systems, but outside of that, give us a little bit of a scope of the company.
Sure, no problem. So Camfil's a large global company, a Swedish company, and back in the 90s, they acquired FAR out of the United States, and that's how they got into the air pollution control business. Their main staple of the business, however, is just regular HVAC filtration for commercial and industrial spaces. And so with the purchase of air pollution control, they got into dust collection and the gas turbine business, as well as a little bit other items that they purchased when they purchased FAR company as well. So here we're making dust collectors for industrial spaces, specifically manufacturing processes, where dust is a byproduct of the process that are happening and required to help either clean the air, improve the safety of the workers or the processes, or to improve the quality of the product.
Yeah, it's a very important safety precaution, especially in industrial settings. And for those engineers out there that are designing these commercial or industrial facilities and are looking at how they're going to incorporate air filtration and dust control, what are some of the most important factors that they really need to consider early on in the design phase?
Sure. Well, there's a lot of things, but I think the most critical item is the actual dust that you're collecting. The dust inherently has a lot of characteristics. The shape, whether it's abrasive, the particulate size, it can be harmful if the particulate's really small in certain substances. And then even to go as far as being explosive. A lot of dusts are explosive. For instance, sugar. Many people don't know, but a lot of dusts are inherently explosive, and in the right environments can be very, very harmful. So when you're specifying equipment, you really need to take a look at the dust information. Type, particle size, how much of it you're going to have, the loading. And then you also need to know things coming from the process or the location, temperatures, operating hours. How much dust are you getting? Do you need to pull away? How much do you need to leave for the product to be manufactured with good quality? And then the last thing is other process information tidbits that may affect the outcome of the dust collector. How much power do you have? How much foot space do you have where you can put the collector? So there's a lot of factors, but I would say the most critical is the actual dust that you're filtering in the application.
Yeah, and that's really interesting. I never even considered that in certain circumstances, something that you wouldn't really consider being explosive can be an explosive, or something that it all depends on so many different factors. I mean, as an engineer, you might be saying, okay, we have to design an industrial or a large scale, let's say commercial baking facility that has a lot of different chemicals or stabilizers or different components that can go airborne. They understand exactly what they have to deliver at the end product, but the engineer might be understanding of, okay, we know how to do it from a mechanical side, but they might not have the chemical, or they might not have some of the other scientific backgrounds. How does Camfil work with engineering firms, the engineers, to understand all those factors and to understand exactly what considerations they have to be aware of, and how do you make them aware of things that they might not know?
That's a really good question. We have a large network of internal salespeople, and we also have a really large rep and dealer network as well to kind of put our name out there and cover the whole nation as well as the globe the best we can, because we know that this is critical. Every day there's more and more manufacturing processes and new dust that we've never even heard of. So we work with those engineering firms as well as the end users, and we have webinars, lunch and learns, just like this interview we've got right here. We welcome people to our facility to go on tours and have some training as well, just to really let them know all the potential hazards, safety risks, everything they may need to know that would come with a dust collection system. I will say, however, it is kind of the last thought when engineers are specifying equipment to manufacture a product. A dust collector is kind of a grudge buy. Nobody really wants to spend the money, but it really is necessary to keep your space clean and safe and to come out with a good product at the end.
Yeah, and I think there's more of a focus now. It's not a one-for-one comparison, but we've gone from understanding the need for clean workspaces to now it's extended almost to every area post-COVID, of course, because now everyone's looking at quality of the air and everybody's taking a closer look at exactly the environmental factors that people are working in. On the flip side of the equation, of course, it's not just protecting those individuals who work at a facility after it's been designed and constructed, but it's also what that facility is emitting out into the atmosphere. So what, should engineers be considering on the issue of emissions and emissions control?
Well, there's a lot that goes into that, and it's really pushed by the EPA. The Clean Air Act in the 60s kind of put this out there, and the EPA came out with a lot of committees that regulate air coming out of buildings. There's also some that regulate air inside the building to keep people safe. So we've got both the environment and we've got our internal environment, external, internal, and there's a bunch of different agencies. All right. And then there's some local agencies or local, the fire department, your local state agencies like California and Michigan specifically have really strong regulations on emissions, what you can admit out into the atmosphere, and then also internally. So it's really important to pay attention to your local authority having jurisdiction, or your AHJ. These are sometimes kind of hard to find, but the OSHA and EPA websites do a great job of kind of pointing you where you need to go. And obviously local engineering firms usually have a good heads up on what's going on. And of course, people like us in dust collection, we know where to get you started. Some states have a lot of permitting requirements and you're going to have to go through the city anyway. Others don't. And it's more of, they want you to do the right thing and take care of the environment.
Yeah. California is always the state that seems to be the leader in, maybe some would say, overregulating at times, going above what's required to on when it comes to workplace safety or environmental regulations on emissions and safety standards. How have you seen California influence other states? Have you seen, in your experience at least, have you seen those standards kind of bleed in to states outside of, the West Coast?
It's coming. They're doing a good job spearheading the effort. I think, employee safety, working in manufacturing my entire career for the last, 20 years, I've been exposed to, I don't know how many different particulates in the air, and California's did a good job. They've also had a lot of litigation internal to their state that spurred that. But other states don't necessarily have to follow suit because the government is. California's leading the way, and OSHA and the EPA are right behind them. And then the World Health Organization on a global scale is already taking it steps further. So California is just doing a good job kind of leading the front. Yeah. Sometimes they have to take a few steps back because they went a little too far. They've got some other items that are hitting them now, such as the fan energy index, really trying to spearhead reducing the amount of electricity consumed using VFDs on all their fans and motors and things like that. So they do a lot of good things, but there's a lot of research that has to be done to back everything. But you do definitely see bleed over, not just nationally, but internationally.
a very good point. It all goes back to, I think, the greater push towards efficiency, doing more with less power. And of course, our engineers are trying to design that way so that they can make sure that they're leading, they're designing for the future as well. And that, of course, goes towards safety. It's not just, we're looking at safety in general, protecting the workers, of course, but then in the normal design and operation here, what kind of specifications do the engineers need to be considering when it comes to safety and the use of industrial dust collectors?
Well, I think we've really touched on them just a little bit, but first is emissions. You're going to have the safety of both the people internal to your building and external to your building. So you need to know what your dust is to make sure you're filtering it properly, the right particulate sizes, and keeping everybody safe. You may require a secondary level of filtration if you're recirculating that air into your building to make sure that there's no hazards coming from the air that you're processing. And then the dust itself, like we noted, can be explosive. The right atmospheres, there's the fire triangle and the explosion pentagon, and every manufacturer should know what causes those. That way you can protect your process and your people. Mm-hmm. There are items, NFPA, the National Fire Protection Agency, really dictates how dust collectors are used and their safety precautions and equipment that can be used. There's testing standards. You can prove this by performance. You can prove it by some mathematics and some other calculations, but there are things like explosion venting, isolation devices, all blast gates, all that may meet some standards within NFPA. NFPA 652 and 654 are the main standards that go over explosive dust. Then there are specific ones for wood, metal, sulfur, agriculture that dive down into each specific market to have protection go a little bit further because it's specific to those dust types. And then lastly, there's NFPA 68 and 69, and that is the standard that regulates those explosion and fire devices and how they're manufactured and what standards they have to uphold. So being the dust collector manufacturer, we work with these companies that manufacture those devices and ensure our equipment works with those specifically so that we can ensure, depending on what the dust type is and the particulate size, that we're protecting everyone from an explosion or a possible explosion or fire.
Yeah, it's really well put. I think to throw a little plug in on ACEC side, I think that's the importance of the coalitions that we have. For example, CAMI, the Mechanical Engineering Coalition. I mean, the nice thing is, at least with ACEC membership, that you have access to talk to peers in your industry, to have exposure to these regulations, to have an understanding of how regulations from one state to another might interact with each other, and the ability to information share, because to your point, there are a lot of regulations that do control the safety issues and the emissions issues, and it's good to be able to share that information. And of course, work with a company like Camfil that can take their, your own expertise and assist those engineers into making sure that everything is compliant with the jurisdictions in which you're working. Let's talk about really the long term here, because specifying for an air handling system, a pollution control system, you want to make sure that you're doing it for the long haul. It's going to withstand a lot of use, and I can imagine these systems really do go through a lot of stress. Talking about long-term costs of ownership, what are certain things that engineers should think about in terms of specifying for the full term of ownership for end client?
Yeah, so there's a couple different ways to look at the total cost of ownership or long-term cost of ownership, and it really depends on the outcome that you're looking for. First of all, you've got your upfront cost, the cost of the collector, installation, ductwork, any of the downtime associated with that, and then on top of that, you've got the recurring costs. Filter change outs, the labor to change those out, the disposal cost of the filters. If it's hazardous material, that could be really expensive. So you may want to look into something that's going to extend the life of your filters as long as possible. This may mean a slightly bigger unit that takes more fan horsepower, so your energy costs go up. Or, you may have a process where your filters are reusable. You're able to wash them once or twice, really get good life out of them. Takes a little bit of labor, a little bit of cost to do that, but you can have a smaller collector, reduce your replacement costs, and go from there. Now, all of this is very dependent on the dust type you've got and what you want to spend annually or biannually moving forward to keep this going. How critical is your process? How heavy does it rely on the dust collection equipment? So there's a lot of things you can do. And I think, as being a dust collector manufacturer and a filter manufacturer, we also make filters that go in other dust collectors. There's a couple things that are really important, the recurring costs. So the filters themselves can have some added technology, glue bead separation, really specific or special medias that are designed for certain applications with nanomembranes or PTFE membranes to shed that dust easy when it's pulse cleaned. Some aerodynamic kind of configurations or inserts into the filters that help pulse clean these better. And then the dust collectors themselves, they could be vertical in orientation or horizontal, meaning the filters are standing straight up in a vertical, and horizontal, they're kind of more stacked on each other. Yeah. So you save a little bit on footprint, but every time they're pulse cleaning, dust is kind of trickling down. It just depends what you're looking for. And there's more than just vertical and horizontal collectors. There's bag collectors, envelope collectors, all those. There's tons of technology that's been around for hundreds of years, but really those pulse cleaning cartridge collectors are where you see great cleanability. So your energy consumption from both the fan and the compressed air to pulse clean those stays really low, and also keeping the differential pressure of those filters low. So you're just not using tons of energy. So total cost of ownership can be affected in many ways, but it really depends on your goal and your dust type of what system you want to specify moving forward.
And again, that also goes to the importance of working together, I guess, in a collaborative fashion, because it's always the engineer trying to be a trusted advisor for the client, so that there may be a call for, hey, this is facility is going to handle this much product at this much time, and then we have to design for that. But then at the same time, to your point, really, if you're looking at full cost of ownership over a long term, you might make the argument of saying, no, actually, you need a larger system, because actually over time it's going to create efficiency, or you're going to reduce the amount of potential for breakdown or removal, and being able to work together to make that argument based off of best practice and of course, history that you have in the industry is critically important for our members to work with a company like Camfil to make sure that you are covering that. So that's a really good point. Lastly, Randy, I want to bring up the idea of the site survey and the importance of a site survey in getting the whole idea of, what are the specifications that you need for a facility. How does Camfil work with engineering firms on those site surveys? What do you recommend on site surveys, and how do they fit into the mix?
Well, the best thing is to get there and get a look at it. Let the experts take a look at it, because there's usually something that somebody's really familiar with dust collectors can point out pretty quickly that will make the whole system work a lot better. That maybe engineers are a little more involved on the process side, and they're not looking out as big. Whether it's adding a drop in a certain spot to make the quality a little bit better, or changing the size of the pickup points. Getting that site survey done, looking at where the dust collector itself will be located in relation to the process can be really critical. You may need a lot of ductwork, you may need a little bit less. Changes in elevation from the process to the collector matter. And maybe there's something else you could pick up in your process as well to help the whole thing the whole way through. You just never know. I think a site survey is best, not only with the dust collector representative there, but as well as the engineering firm or the installation crew, to really just finalize everything and fine tune that system design. Because in the end, you really can't size the system correctly for the best total cost of ownership, like we just talked about, without seeing all the variables that are in place.
Absolutely. Well, Randy, for those out there that are interested and are involved in projects or going to be involved in projects that are going to require an industrial dust collector, how do they get in touch with you guys, and how should they reach out?
The best way is through the internet. The good old trusty internet. Yes. We've got two great websites. We've got camfil.com and camfilapc.com, and you will be able to instantly get a hold of somebody who can lead you to a rep or a sales manager, territory manager right in your area.
Fantastic. Well, Randi, I really do appreciate the time that you spent with us, and I think this is very important to get out there because, it's nice to be able to dig into some of the more technical aspects. We talk a lot about, esoteric kind of business things. So, actually talking about what you need to do to specify a piece of equipment is always a nice thing to be able to focus on in the podcast. So I really do appreciate your time.
Yeah, thanks for having me.
Fantastic. And again, this has been Engineering Influence Podcast from the American Council of Engineering Companies, and we'll see you next time.